You're about to listen to the Complete Developer Podcast, the podcast by coders, for coders, about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Welcome to another episode of Complete Developer Podcast. This week, we are talking about multi-tier architecture in software design. We'll briefly cover single and dual-tier approaches, spending the majority of the episode on the three-tier architectural design. In a three-tier design, the client side will be a lot smaller than with the two-tier client-server application. The three tiers are presentation, or user interface front-end, application, or the business logic, and the data, or back-end. But before we get started, Will, what have you been fighting this week?
I haven't really been fighting so much. Right now, it is, as we're recording, it's July 25th, so this is going to sound out of date by the time this comes out. But what I'm working on at the moment is getting a working development stack for .NET Core up for myself. And so I've got a little project that I'm actually porting. It's my little code generator deal that I use. It's really not that little anymore, but it was based off of SQL Server and standard, .NET. And now I'm trying to port it to be based off of Postgres on .NET Core.
Interesting.
And so like with the RTM, I think it was RTM or RC2, I forget which, of .NET Core, I couldn't do Postgres. So I was dead in the water there. So I kept the project and hung on. And then when they updated, I updated my references and voila, I could get on Postgres. So the next thing was getting in-unit up and working. And I managed to get that either Friday or Saturday. I forget. It was Saturday morning. And so I've got that working, even though it's console only, which is a little more ghetto than I would like, but I can live with it. I have some sort of ability to get a feedback loop.
That's cool.
And so with that, I've also been re-architecting the app from T4 templates. Because we now have string interpolation in C#. So there's a lot of things I can do that are clear enough because T4 is not moved over yet. Mm-hmm. And so I'm making it into a console app, and I've actually been going through a whole lot of best practices stuff on how you build console apps, and I actually have controllers in there. Oh, wow. For that. Like to control the flow, because it's the same principle you would have in an MVC app. Yeah. And that never clicked for me until I was there going, wait a minute, I've seen something like this. I know exactly what I need to do. So I'm building that out, and it's also breaking it down where it's testable.
Oh, really?
Because I can build those. I can load one of those controllers up and say, "Here's your arguments." Yeah. That are passed to you, and I can nest them, and I can do everything I need to do, and so it's working great.
That's awesome.
That's what I'm doing at the moment. How about you?
Well, I have been fighting Node. You guys know I'm primarily a .NET coder.
So you're fighting Node. So you punched it and then you waited for the async block?
Yes, exactly.
Wait, you can beat Node in a fight. There's no blocking calls. That was a really bad joke. I'm so sorry to the audience.
I'm so leaving that in too.
Yeah, you are.
So like I was saying, I'm primarily a .NET coder, but because of my front-end experience, I've one of the roles that I have at my job is I'm a liaison between the front end and the mid tier. So the first few weeks that I was working had me primarily on the .NET side. I barely looked at the front end code. And so now I'm moving over to help out with some of the Angular stuff. And I've been fighting to get my work machine set up to work on the front end. And I've been having the worst time with Node. It would let me install Grunt via NPM, which for anyone that doesn't know, that's Node Package Manager.
What version of Node and NPM did you have? Because I've had this problem where I had a really old version that Windows was like, oh yeah, here, use version 0.01.216 or something. It's like, this was the first... it's the first little bit of chicken scratch that somebody over at Google did, and that's what they're going to give you.
Yeah, well, I mean, this wasn't a brand new machine, so it already had Node on it, but It was an older version.
It's always fun to roast marshmallows on somebody else's dumpster fire, isn't it?
Yeah. The thing I kept running into was that the command line didn't recognize grunt as a command.
Did you look at your system paths?
Yep. I tried updating NPM and Node to no avail.
Wouldn't let you update.
Would not let me update. I downloaded the latest stable release of Node, and it would get about halfway through the install, and then it would back out. Yeah.
Because you don't have admin permissions on your box.
Nope, I do have admin permissions.
Okay.
Yeah, that wasn't the issue. There is a part of Node called performance counters that, to the best that we can figure, it's something specific to Windows 8 and above, and we're running Windows 7.
That might have explained some of my earlier problems with it as well.
Yeah. So, like, my boss is the one that found this, and he told me to take that out of the install. As soon as I did, latest version of Node, from there, Grunt was easy to get installed and running, so no more problems.
It's weird that they don't, in the installer, they don't sort that out and go, hey, this is for a later version of Windows. Mm-hmm. You know, if it should either be, okay, we don't support Windows 7, which is dumb.
Yeah.
Or, hey, this feature isn't supported. Don't let them turn it on and crash the installer. Like, that's very strange.
Like, at first I was trying to install the latest version, and then we went back to the latest stable version. Still would not install because of this.
Man.
Well, also, my mom broke yet another lawnmower. You guys heard me talk about how she broke the lawnmower before.
You know, at some point, you're going to have to keep her away from small engines.
Yeah.
Like, just period.
Well, she didn't, this time she wasn't trying to do any maintenance on it. And it wasn't the engine. I've not let her use the riding lawnmower that she has, just because I know that yard belonged to the house belonged to my aunt and uncle, and I used to mow it when we were in college.
Right.
And I don't know if you remember me driving down and doing that.
Yeah.
It was a good $60 a week.
Yeah.
So I know all the ins and outs, the pits and the rocks and stuff. So I don't let my mom on the riding lawnmower. I let her, she wants to help. She can get out and, sweep, and she even gets out and gets the push mower around the trees and stuff. So
didn't work too good, did it?
No, she got, no, it didn't. She got out on the riding lawnmower because there was a lot of mulch built up. There's like the side lawn is
okay, I got you.
Really thick, especially right
and
over.
So she smacked that mulch and broke the blade,
bent it, and didn't know this. So she puts it up. Well, I got out there Sunday, went over to help out, and I went and mowed the back lawn, the very far back with all the big rocks and stuff. So I'm like avoiding everything. I noticed a couple of times that I hit some dirt mounds kind of hard. I'm like, that shouldn't be the case. Well, until I got around, like I finished up the very back, and I was riding it around to the front, and I started outlining the front lawn. I got to this one part where this root from a tree kind of comes up a little bit, but it doesn't really get above where you cut the grass line. Almost threw me off the lawnmower when it stopped.
Whoa.
Yeah.
Yahtzee.
Yeah.
Yeah, that's a really uncomfortable feeling, having a lawnmower or a tractor.
Yeah.
When a tractor locks up on you like that, especially on a hillside, that's uncomfortable. You don't want a big old Kubota rolling over on you.
But yeah, I mean, it stopped, and I was like, oh, all right, something's wrong. So I rode it back over to the back of the yard and looked under it. Of course, it was turned off, and sure enough, you could see the blade just sticking down.
Don't you love all the mechanical stuff? Isn't it fun?
Mm-hmm.
So, that said,
let's roll the music. This week for IoTs, I have something kind of fun and maybe a little overdone, but this is kind of a new take on it. This is the Velo Bling Bling. This was created by Peter Schmid of Switzerland, and it is LED lights for bicycle wheels that can display images or text with a Bluetooth or USB interface. It uses about 32 RGB LEDs that are controlled in real time, and it's just kind of a fun project. It does require some advanced skills and some soldering, so we know Will needs to be careful if he does this. The description says it takes approximately 20 hours to complete, and has some really cool features like a built-in cyclometer with a pressure altimeter, and it can even be configured with Bluetooth low energy via a smartphone. There's also about 50 custom pictures already created that can be added to the bicycle and show up on the wheels as they're spinning. The hardware is pretty simple. It's 32 LEDs, low power accelerometer, an altitude pressure sensor, Bluetooth low energy module, Kinetics K2X USB MCU, Cal effects sensor, microchip, and for testing and setup, they used a Freedom board as opposed to one of the other boards. And then the software is actually a custom firmware binary that you download from the author's blog. And so I've got links to both the Hackster.io article about it and his specific blog on doing this with where you can find the custom software. So it's pretty cool. Who's talking to us?
Well, this week we have a comment from a friend of mine, actually, John Beluca. He's in the mastermind group with me that I meet with on Wednesday nights.
Awesome.
But his comment was, even for a longtime software developer, it's great to hear these well thought out discussions of the day-to-day challenges in the industry. Also, excellent show notes.
Well, thank you, John. I do put quite a bit of effort into making our show notes, making our outlines viable show notes.
Yeah, and I don't put effort into it at all. That is all on Beach.
Yeah, I tried to get him to do it once, and Wednesday night he sent me a text. Hey, I didn't get to this. Can you do it?
Yeah. We didn't, we figured out that was not a part of the workflow for me.
Yeah. So we've got some complete developer swag just for you. And if you guys would like some CDP swag, write us a review in iTunes. We love our 5-star reviews. Or leave us a comment on the website. We like to talk to our listeners, get ideas from you guys, and answer questions. We also post all of our shows on Facebook, Google+, Twitter, and LinkedIn. And you can look us up on there, follow or friend us. We definitely like to talk to our listeners and have gotten a few show ideas from some of them too.
Yep.
This week, we are talking about multi-tier or the different tier approaches to software architecture. We're going to start off with the single tier approach. And this design comes from back in the old days of the mainframe computers, where everything is done on a single computer with all of the resources attached to that computer. And it was accessed through terminals without much logic or processing individually.
Single tier is obviously the simplest case, right?
Yeah.
That's where you start, because you're like, I need an interface that does this, puts data in this data store, gets data out of this data store, even if that's a file system. So this is where everybody starts. This is where the whole thing started evolving. And then after a while, it started getting to the point where, hey, that individual box isn't going to cut it.
Yeah.
By itself. It's like we have all these clients out here, so we're going to shift some of the load to them.
And that leads us into the dual or two tier.
Right, which is your client server architecture. And this was kind of what was going on when I was coming up.
Yeah. I have on here. Yeah. It's like enter the age of the personal computer. The personal computer necessitated providing personal software.
Well, it was that, and it was also the economics. The other thing that drove this is computing power got, some reasonable degree of computing power got cheap. So you could put it on the end user's computers and then just work your central machine could do the things that only it could do. And so it was actually a way of making your users pay for computation.
Yeah. And that's one of its biggest advantages, is that it is less expensive than mainframe or single tier. However, the connections to the database server can be expensive, with limitations on how many users can be connected at once.
Yeah. I mean, like SQL Server, they charge you like $1 for every transistor in the... Never mind. That's not... I forget what it is. It's like their SQL pricing is insane anyway.
Yeah.
But it's an evolution thing. And so like if you think about this in terms of economics, the pieces fit a little bit easier.
One concept that we've mentioned before is Gall's law, which is more complex systems develop out of simpler systems.
Yes.
And this follows that same pattern to a degree. It's following a pattern. It's not like exact.
Well, and it keeps getting more complex, right? Like you're going up to 3 tier. The stuff I'm working on at work has got a database tier, a business tier, and then it builds a view model and pitches it to the client, and then it does the data binding there. So it's like it's almost like there's a 4th tier in there with the web server controllers and all that kind of stuff.
Well,
so
yes and no. I mean, is that 4th tier its own separate file, separate from everything else?
Yeah. It's executing on the client, and then you have your web forms or your controllers on the back end. They do some logic too.
They do. That's true.
They marshal the data between the 2 points and handle all the calls and all the HTTP stuff. And so it's one of those things, like it just keeps on stretching out. But most of the time what you're going to encounter is a 3-tier architecture.
Yeah. That's the majority of what's out there. That's what I work on.
Yeah. Because most of the time too, if it gets past 3 tiers, people just flat out go to microservices.
Yeah.
At this point, because it's like, okay, at some point you stop stacking blocks and you kick the tower over, and that's kind of what microservices is.
And we're going to have a whole episode just on microservices.
Yes.
So we won't get too deep into that right now. As we've kind of talked about a little bit, the 3-tier approach separates the functional process logic from data storage and user interface. These are all 3 developed and maintained independently on separate platforms.
They tend to, although I do find that most people tend to have, like, they're deployed on 3 separate platforms.
Yeah.
Most people, when they're testing, debugging, all that stuff, they are doing it on one box. It's just,
that's true.
One part of it's JavaScript, one part of it's SQL, one part of it's C# or something else in the middle.
Yeah. So to break these down, we've divided them into the 3 tiers. And then I found a really interesting blog post that listed rules of the 3-tier architecture. And then we'll close out the episode talking about some of the benefits and drawbacks of the 3-tier approach. So to start off, we have the presentation tier. This is the user interface stored on the client. This is what the clients see. It gives the user access to the application, presents data to the user, and can permit manipulation and data entry. Well, that last bit's a bit optional. You have 2 major types of interfaces. Your traditional application, which would be like your desktop, your mobile app, things like that, and then your web-based applications. The client has their own local data sources and stores. So this can be like data tables or how the data is presented. So graphs and charts are developed on the client side from the data. And the languages for the presentation tier tend to be like, well, part of it is the user interface design. But what a lot of people think of with presentation tier, also known as the front end in web development terms, is dynamic HTML.
Yeah, which is a really old, archaic term for what it is. I mean, it's still the same thing, right?
Yeah.
It's like, but that's fallen out of fashion to call it that, because it's, yeah.
It's really not, but that's what it
yeah,
when you look up this information, there's a lot of great resources.
And some of them are old.
Yeah, some of them are very old, but they're still very good.
Yeah, they're, some of these sources are all like, "Hello, good sir, let me tell you about the Great War." Yeah.
Well, web services, really. And that'd be your HTML, your CSS, and your JavaScript.
Yeah. And those are the primary languages. You used to see a little bit of Flash. You used to see a little bit of Silverlight. They have been burned at the stake as heretics now, and we're all better off for it. But there are occasional other things that you'll see in there as well.
Like PHP?
No, like for the front end.
Oh, for the front end, okay.
Like occasionally you'll see some use of things like scalable vector graphics. And then there's stuff like WebAssembly that's coming out, and there's a few other little things like that. You used to see Java applets. You don't really see those much anymore.
No.
Thank goodness.
The presentation tier only interacts with the application tier. You want to keep your presentation separate from the logic of the application, and that logic acts as a buffer to the data, because you don't want a direct connection between your user interface and your database.
Right. And this gives you a lot of things. One thing it gives you is caching on the web, right? And you would be surprised at how much web traffic can be cut out with very simple caching mechanisms that are built into the fact that you're doing HTTP.
Yes.
Another thing it gives you is, like you said, is protection. Is that layer of abstraction between your data model and your view. And the reason this is important is the way that I look at data on the web page has nothing to do with the way that it's structured in the database. Exactly.
It can be heavily manipulated in the
It can be aggregated, rolled up, shoved into an object graph. That's like the stuff I'm doing at work right now. I take all this data that's actually coming out of our business classes, and I roll it up into this object graph that I serialize and pitch down to the client and load it into knockout models.
Okay.
And so essentially on the client side, I have a view and a business layer that's calling back and treating the business backend as a data store, because it doesn't care.
Yeah, that makes sense. What your presentation tier is doing is it is sending requests to the application tier and receiving responses from the application tier.
Right.
And that is all the communication it should have with the other tiers.
Yes. Now, where this gets interesting is some stuff that's coming up that's getting to be a bigger thing, right? Because you and I typically think about this in terms of HTTP, right? I send a GET request, or I send a POST request, something happens, and then it pitches a result back. However, that's not the only mechanism, because you can also do this with WebSockets. You're keeping a live connection between the two and passing data. In other words, it's agnostic in terms of transport channel.
That's true.
Just want to throw that out there, because that's going to be a bigger thing.
So your application tier, also known as your logic or business logic or mid-tier,
or place that the programmers like to live.
Yes.
Because it doesn't have the problems.
Yeah. This exists on your server, and it assists in resource sharing. It consists mostly of business and data rules, such as business algorithms, legal regulations, and structures for the consistency of the data.
Yeah. And of course, this varies, like this consistency of data structures. At the business tier level, I will say that this varies from what is at the database level, right? Because the database does data things, but this is consistency of business data. And let me give you an example. A order detail line has to have an order as there's going to be a foreign key constraint from that order detail to an order. That's a database concern. The notion that, hey, if I have an order, it has to have a line on it is not a database concern. Like, that's not enforced with referential constraints. That's enforced with, hey, yo, dog, this is busted in the business layer.
Well, it's like the application I'm working on at work. One of the major functions of our business layer is to take the data coming from the database and translate it.
Same where I work.
Yeah, to go out to the presentation tier.
Yep.
And when data is entered, to bring it in, check to make sure it fits, it matches the criteria to go into the database, regex, all that fun stuff.
Yep.
And then converts it and passes it on to the database.
Yeah, and as an aside, I want to throw something else out here too, just throwing a little curveball. During interviews, you get asked, do you do validation on the client side or at the business tier? What is your answer for that? What is the
Yes.
best? Yes, the answer is yes.
That's the answer I always give.
Because you do it on the client side because it makes the client side faster. You do it on the business layer because you catch things. Because otherwise somebody go to the JavaScript console and send you malformed data and it just goes in.
Yeah, exactly.
Part of the deal with separating this is the security boundary.
Mm-hmm. It also can solve critical business problems in this layer. And the idea is that it can be used by all applications, moved to different locations, and generally be interchangeable. So, for example, you could have your UI trade out your mid-tier
Right.
with a different one.
Yeah. I mean, that can be a little bit tricky.
I'm not saying it's easy. I'm just saying that the idea, the concept behind the application tier is
I've done this because what you do is you basically say, here's a stub that, when it gets this value, or a mock, I guess it wouldn't be a stub.
Yeah.
Sorry to get pedantic, but it's like, here's some data. Here's what you get when you pass that data in, and you can build your test framework on the client side. And that's the best way I've seen that done.
Yeah. And these are typically what you would consider your Turing complete programming languages. This, like Will said, this is where most programmers like to live. This is what most people consider a programming language.
Right, because you're actually solving abstract problems, not going, oh, how do I keep users from clicking on this button twice and double posting a payment?
Yes.
Because they're idiots.
And these are languages like C#, C++, C, Objective-C,
Ruby, Python.
Sorry, I just I listed those out. I started with C# because that's what Will and I both write, and just kept going with the C's.
Yeah, I don't know that you would. You can use C. I've seen CGI apps. I've got a friend that does that.
Oh wow!
For web, and God bless him.
I was explaining to someone last night what high level versus low level languages are. Yeah. Because when I mentioned what she was telling me her dad does, I was like, well, that's really low level programming. She's like, oh, so it'd be like really easy for you? I'm like, no. I was like, let me explain what high and low level
Think
are.
like scuba.
Yeah.
It's low in terms of scuba.
Yeah.
In other words, assembler is right at the bottom of the Marianas Trench.
Yes.
In a wetsuit.
Yeah. So, and the application tier is really the only tier that communicates with both of the other tiers. So it is your communication hub.
Yes.
And it acts as a buffer between the client and the database. And it will receive requests from and send responses to the presentation tier. So the presentation tier is going to send requests, and those will be received by the application tier. And then after some processing, the application tier will send a response to the presentation tier. And then it's the opposite for the data tier. So the application tier, the logic tier, is going to send requests to the database.
Right. And get a response from it.
Yes. And get a response back from it.
And it can also be the database, other external data services. I mean, part of the deal with the business tier is that it makes the client tier not have to care where the data is coming from.
Exactly.
And it could even be a thing of, it's very much delayed. Like I've seen a thing where the client will call the data, or will call the business layer and go, okay, the business layer sends something back, says, hey, I'm not ready yet. And the client waits and it calls again.
Yeah.
With polling loop type stuff. I mean, it can really very much decouple the front end from the back end. And that's what you want. You don't want to do taking a poke at Microsoft, but you don't want to do the typical Microsoft thing of, oh, yes, let me create a web interface to my database. And I'll put it out there as a sample on MSDN because that's what we do. So
I actually did get a lot of this information from MSDN. They had some really great
they do. But some of their code samples, you don't want to do that.
Oh, no. The thing is, sometimes it makes me wonder if they're
trolling me.
Yeah, or if they're describing something and the code sample is like, this is how to do this, but it's not a good idea.
Yeah.
Like they had a really great article on the dual tier approach. Yeah. I got a lot of information from that. A lot of stuff I didn't put in here just because we're focusing on the 3-tier approach. But, there was a lot of great info there. I really would not use code samples from that.
No, I clean up quite a bit. So beyond this, the next tier obviously is your data tier. And this is actually a place I'm increasingly finding myself liking to live. And the reason for this is I've realized in a lot of cases what I thought were business constraints really are data constraints.
That's really interesting because when I first started, you remember when I first started
and I
learning,
was big in the database when I first started.
Well, no, when I first started learning with you, I was really heavy in the presentation tier because I could pick that up.
Yeah.
And you could be a little artsy with it and stuff like that. You had some creativity. And that's where I found the data and the application stuff fascinating, but that's where I was most focused because that's what I could do.
Yeah.
And now that I've been working, I'm really loving the application tier.
Yeah, and that'll probably be your favorite place for a good long while. The thing with the data tier that I like is that it exposes you to decision makers. Because you think about what, when they have a audit, when they have something regulatory happen, which they're going to have at some point, where do they go? They don't go to the front end guy, right? You're the person that they rely on, and the way that you structure that has a tremendous impact on the company.
Well, I'll tell you, being at the application tier level, like that's where
you need to be right now.
Yeah, that's where most of what I do. But because of that, I've got friends that are like, I'm friends with our lead front end developer.
Yeah,
he's a great guy. Our DBA, he came to me to ask me questions about how I got back downstairs from our meeting this morning faster than him. It's like, I left the room before you did. How did you get here before me?
Yeah,
and I showed him the back stairway, and he's like, I didn't even know about this. And it was just like,
the middle tier is also really good for networking. And I think some of it too is, it's almost like a career progression thing that like you move back in the tiers the further along you go.
Yeah, that makes sense.
And I'm not sure exactly, like I'm not really sure that's a thing, but it seems correct.
Now also we're going to be talking in a few weeks about full stack development. And this is kind of, I haven't mentioned it yet, but this is kind of a setup for that. I was saving this for the end, but I'll go ahead and say it. But this is a setup to understand what each tier is so that when we talk about what it takes to be a full stack developer in a couple of weeks, it will make more sense. This is
right.
Like a pre-episode to that, because this is good information in and of itself. And I didn't want to try to combine the two because this had enough to be its own episode. So the data tier, this is where primarily it's going to be database servers.
Yeah, and typically it's some variety of SQL or increasingly NoSQL.
Yeah.
Of course, the thing with NoSQL, right, is you're still typically using some sort of query language. Mm-hmm. You have MapReduce, you've got various things for like graph databases. You have key value pair lookups, all these kind of things that go on.
And I just want to take this moment to throw my lot in with Richard Campbell, and it is SQL, not SQL.
Well, it was SQL originally, and then it became the acronym SQL, which they decided meant structured query language, if I remember correctly. So now it's kind of all those things.
It was the way it started out was it was for the second database.
Right.
It was a language for that. So they called it SQL. Found out that they could not trademark a word.
Yeah.
So they cut all the vowels out, but it was still called SQL.
Yeah.
And then, after the fact, which typically happens with acronyms, added the meaning.
Yeah.
So, I just saying, it's SQL.
Yeah. Nobody, I won't say nobody cares, but because
we're pedantic
programmers
nerds.
Programmers are pretty good about being extremely pedantic. So, there's a lot of people that care way more deeply than they should.
Mm-hmm. And guys, if you want to prove me wrong, leave us a comment.
Yeah. How about that?
If you have a valid argument to what I'm saying, we'll read it on the air.
So SQL's got a couple of pieces. One of which is data definition language, at least with your relational data stores. It's like, hey, create this table. Here's the columns in it. Here's the constraints on those columns. Here's the foreign key constraints. Here's the indexes. Here's all the different bits and pieces that go on there. Here's the triggers. Mm-hmm. And the other part is actual data manipulation language. And that's insert a record, pull these records, update these, delete these. It's, two pieces to the language. A lot of your database servers also, in addition to these things, have got stuff that's more properly called batch processing. Mm-hmm. Things like, hey, fire this stored procedure at 3 a.m. That it's almost like, hey, this thing is starting to become my premise is that the database has become a microservice written in SQL for this very reason. Is there's too many things that are not those two language features.
Yeah. Well, I mean, I would say SQL's like any other language. It originally started with a set definition in small and grew.
Yeah, it is.
Because, JavaScript, look at that. JavaScript can be used on the back end now.
It can be used in the database.
Yeah. But the data tier interacts with only the application tier. It is very important that data be kept separate from the application and the business logic.
Right, because if your web server goes down, you don't want to lose data over that.
Exactly.
Unless it's a transaction that actually legitimately has not completed, mm-hmm. You don't want that gone.
Yeah.
Now, I've increasingly seen a thing where people will actually store the entire database in memory.
In memory?
Yeah. Because you think about how big is your normal database and how much RAM does your server have?
Well, that's a good point. But
right, for perf, they'll do that and then they write off somewhere else. And actually, SQL does this under the hood as well. Yeah. But that's a very interesting approach to avoid all the long calls.
Well, I know when I was dealing with an issue, I think I told you about it. I was one day last week, I wrote probably 5 to 800 lines of code because I was writing tests. And the next day, I spent all day on 2 lines of code.
Yeah.
And of course, I loved what you said. I've said this several times since. We don't get paid to type. We get paid to solve problems.
Yeah.
But that second day that I was working on those 2 lines of code, when I really just was at my wit's end on getting that to work, I broke it down. And at one point, just to understand how things were working, I was pulling the entire database in.
Right.
And searching through it. Of course, in a testing environment where the entire database is 30 or 40 records, that's okay because I'm trying to figure out why the code isn't working or what I need to do to make it work. But
past that, it kind of hurts.
Yeah, but it's one of those things. I kind of see what you're saying with that, bringing the whole thing into memory because
it's faster.
Yeah, it is.
And a lot of places will actually do things where it's okay, you have a shard of the database, and it's hey, load this shard up on this node, mm-hmm. and when somebody needs something from there, call that. You don't call the actual store, but when they update, that calls the store. So it's separating the reads and the writes.
Almost be another layer.
It is.
You were talking about another layer between the application and the presentation tier. This could technically you could make a 5-tier approach.
You can go any number of tiers.
And, there's a whole set of articles on N tier.
For a little bit of drunken programmer zen, realize that in a front end application, for instance, I have a model that I'm working with. Right, I can even have controllers. If I have a single page app, mm-hmm. right. So there's your business layer. And then I have the actual GUI, the HTML and whatever bindings. And then what does it do? It talks to a backend, which happens to be the web API, and it's doing business logic. It's treating the database server as a backend, but it's rendering views, which happen to be JSON that are serialized down to the client. So you have 3 tiers in each of your 3 tiers, if you want to look at it that way. Because you can do that at the database level as well with views. See what I'm saying? It's it's
turtles all the way down.
It's very,
or it sounds very much like Inception.
Well, the thing is you're abstracting it at a layer that you can comprehend it.
Yeah. Well, and it makes sense. It's like you take you take this is architecture, so this is like the overall is what we're talking about, but you can take this same concepts and apply them to each tier.
Yes.
So to think about that, guys, because that's something that, that'll keep you up at night. Or
Yeah.
not. I don't know. Might put you to sleep. Who knows?
Yeah, it'd put you to sleep. Trust me.
So I found a really great article, and I mentioned this earlier, by Tony Marston on the 3-tier architecture, but the part that really just jumped out to me that I had to include, and this isn't exactly verbatim, but it is very, very close, so I want to give him credit for it, are the rules of the 3-tier architecture. And remember, guys, this is like having a third person in the room with us, because it's going to be opinionated, and we're going to sling stuff at it, so heads up. Number 1, the code for each layer must be contained with separate files which can be maintained separately.
Yes, with caveats.
Of course, go ahead.
Contracts between the tiers are a situation where this may not be true. And I'll give you an example. If you've got two, well, it's not necessarily that the files are separate because they should be. It's that the definitions are the same. So like if I have a Knockout.js model that is deserializing JSON that's pitched down from C#, I want those things in sync. I don't want the C# to be throwing something that doesn't come up in the JSON and vice versa.
Well, yeah, I mean, that's like the...
So it's separate. It's separate not in the sense of prison cells, but separate in the sense of meeting rooms.
Yeah. Well, yeah, that makes sense because
they share a door.
Well, like I was talking about the application that I'm working on, a lot of the business layer is just in the converting of data.
And you have the same thing further down, right, between the business layer and the database.
Yeah.
Typically, you'll have a mapping layer between the database and objects.
Yeah. Well, what I'm getting at is the way that the application was designed is to where the naming for each is identical.
Right.
So that it just flows and it makes sense because you look at one and the other and go, okay, that I know what
this matches to this.
This matches to this, and I don't have to go look at.
Are you doing manual mapping or using AutoMapper?
Manual.
You and I need to talk, bro.
I didn't do it.
Yeah. So now the next thing is each layer can only contain code that belongs in that layer. In other words, don't put your bits where your bits don't belong, Mr. Clinton. Right. So business logic has to be in the business layer. You should not be putting that in the database, right? Because that hurts. Like that SQL is not really the best place to explain that logic. You don't have all the tools there. Same thing as you wouldn't put it on the client side because then it makes it really easy to hack around.
Yes.
Same thing with presentation logic. You do not want to be shaping your presentation in your business layer. Now, you may be building a model that you're passing down, but that's as far as it goes. Like it shouldn't be writing HTML. Now, you're going to bend that rule. I'm just going to go ahead and tell you because that's life.
Yeah, that makes sense.
Data access logic and data manipulation logic in the data access layer. Same thing. Your app typically is going to have to care about foreign keys and things like that and going, hey, let's make sure that, this record we're dependent on is created before we try to push this other record in because that makes it performant and you can handle those error conditions easier. But if that's all you're doing and you're not doing your data management code in the database, you have a problem. I know a lot of developers that are like, oh, I don't want to put foreign key constraints on any of my tables because that slows things down and it makes it harder in the business layer. It's like, well, at that point, your table is a key value store of IDs and junk. And the data will be junk at some point because somebody will insert bad things in there and you're going to have a hard time keeping that from happening. So yeah, you got to separate those concerns out and realize what each piece's role is.
Yeah, exactly.
The presentation layer gets requests from and returns responses to an outside agent. That's usually a person, could be another piece of software. Increasingly, this gets a little blurrier because that's, I know it's one of his rules, but because, hey, the server can push things at clients now, This was probably written, if it was more than 2 or 3 years ago. Honestly, even if it was written now, a lot of people wouldn't get that. The presentation layer can only send requests to and receive responses from the business layer. That's, generally speaking, accurate-ish. So it's
the big thing here is you don't
within
want
your app.
Yeah, I'll say the big thing here is you don't want your presentation layer talking to your database.
Right. But if it talks to a different business layer, or a different presentation layer,
yes, that's different.
That kind of stuff happens too. But for the most part, like I'm laying these out so that people get the logic behind it, not because usually the not the contradictions, the exceptions explain the rule.
Mm-hmm.
And so that's kind of where I'm going on this.
Next, the business layer can only receive requests from and return responses to the presentation layer.
Right.
It doesn't receive requests from the data layer. Generally speaking,
yes. I've seen some weird designs though. Typically with a 3-tier architecture though, you're not going to do that. And that may talk to other business layers on the back end. Because it's business layer is an arbitrary layering.
And then on the other side of that, it can only send requests to and receive requests from the data access layer. Responses from, yeah. So basically, the business layer is not going to send a request to the presentation layer.
So
generally
speaking, saying the data layer, are you saying the C# code that wraps the database as the data layer, or are you saying the database is the data layer?
The database is the data layer because it's a completely separate entity.
I've seen it talked about both ways, and I've seen people even draw the diagram where the data layer includes the C# code that talks to the database.
No, that
so like any way these people draw these lines can be pretty weird sometimes.
Yeah. No, I'm glad you asked that because that's a very good point that I didn't think about. But when I say I like the structure where I work because it's a very great example of the 3-tier architecture.
Yeah.
So we have all of our front end is written in VS Code. All of our business logic is written in Visual Studio 2015.
C#. Yeah.
Yeah, C# and XML. And,
yeah.
But all of our database stuff is in Oracle.
Yes. You'll find that the 3-tiered architecture a lot of times developed because it mirrors the communication structure of the organization.
Mm-hmm.
And in people's individual silos. And, hey, how do I keep from stepping on this guy and how do I keep him from stepping on me?
Yeah.
And that's typically what you see with these designs. That's why you see weird stuff like, oh, yeah, this is part C# and part database, and it's the data access layer. It's like, well, because the database guy knew some C# or vice versa.
Mm-hmm.
Like it's a mirror of the larger organizational structure. It's just how it works out.
Well, the language that you use at each level is less important than the differentiation between the levels.
Yeah, and the language is optimized.
Yeah,
for the level in question. That's
typically speaking, yes.
Yeah.
So the data access layer.
What? You don't have any VB? Sorry.
Oh, no.
Sorry,
I haven't done basic in a long
had to poke
time.
at the VB programmers.
So the data access layer can only receive requests from and return responses to the business layer.
And I'll throw out another thing here is that a lot of people like to use their database as a communications mechanism, which is ghetto. You don't really want to be doing that. Of course, we're doing that where I work, so I can't really complain. But it's a thing where, hey, some other app wrote into the database or some other database wrote into my database, and I react to that by polling. That's that's obviously not ideal, but it does happen.
Yeah. Each layer should be totally unaware of the inner workings of the other layers.
Yes. I will agree with that, again, with caveats, because all abstractions leak. Like, it's not that it should be unaware, but it shouldn't be peeping.
Yeah, exactly.
That's the best way to put it.
For example, the business layer, it should be data agnostic. Or database agnostic.
Yes.
And not know or care about the inner workings of the database.
Yeah. But in practical considerations, you do occasionally have to care because you have to go, okay, well, there's 50 million rows in this table. I need to search on something that's indexable.
Yeah.
You try to keep that to where it cares as little as possible. Same thing with your front end.
Yeah.
Knowing how those pieces work. It's just, that's life.
Exactly. Now, some of the advantages and disadvantages of the 3-tier approach. The advantages include reusability, where you're able to share and reuse components, distribute them as needed. There's flexibility, where you can deploy and redeploy components, keeping up with changes and growth of the application, such as user base, data, transactions. As the app grows, you can grow with it.
And you can scale the layers independently of each other.
Yes, which leads to the very next one, scalability. And this is it. The benefit here is you can divide large projects into simpler ones and distribute the workload amongst programmers with no need for connection to the database for every client. And finally, data integrity. And this is not an exhaustive list. It's just some of the highlights that I picked up.
Yeah, I've got a whole book on this somewhere around here.
And this is basically the mid-tier ensures that only valid data is allowed. So, you don't have any little Bobby tables.
Yeah.
As we've discussed, that joke never gets old.
Yeah.
Guys, over at XKCD, that's like one of the best you've ever done. So
yeah.
And then...
because they totally listen to our podcast.
I'm sure they do.
We're that vain.
Yeah. And you also get better security because there's no direct access to the database.
Well, and it also cuts your client license cost. Because how many open connections is everybody and their mother going to open on the database? Versus, my web server's opening a connection.
That's very true.
And the overhead of those individual connections, the ability to use pooling, caching, all those kind of things.
Yeah, exactly.
Which are also security features, by the way.
So a few disadvantages are increased complexity. There's more points of communication, so more places where communication can break down.
Yep.
And you're kind of going to need a little bit of a larger team for this.
Yeah, although you'll find that if you get competent people, that doesn't hurt as bad for the most part, because they can figure out how to do end-to-end, and they can figure out how to communicate amongst themselves and be effective. It's when you try to use commodity developers and just throw bodies at the problem, that's when your team size just explodes if you do this. That
makes sense. Also, physical separation may affect performance.
Let me tell a story real quick.
Please do.
There was a company I worked at here in town. And we won't talk about their name, but they're like if you made a call to their website, what the business layer used a set of web services as its backend, and then those shaped data and gave it back and talked to the database. So it was that multi-tier type design. And what they like to do is say, hey, I'm logging in. Here's my username and password. Seems reasonable. It would call a web service. The web service would figure out what permissions you had, right? So you're passing this little chunk of data. This thing is building this massive object graph. And of course it had to be in XML because JSON is scary.
Really?
Yeah, don't even, don't go there, man. So it was sending, and the app that they had was very much a monolith. So like if you were the CEO of the company, which was, there are multiple thousands of people that work there. If you're the CEO of the company, you have access to anything you want. If you're a C-level officer, you have access to most things you want. Like you have to get way down in management before you have a small set. So this thing would pull back this entire object graph. And it was serializing it to XML, pitching it over the wire, validating the schema, then deserializing it. Then rendering that as HTML, pitching it over the wire. Yes, it was exactly everything you could hope for from that kind of setup. Sometimes it would take a minute and a half to log in and get the screen that you were landing on because you had too many permissions. And by the way, the people that had the worst problem of this thing were the people that were most able to fire everybody. So like latency is a big concern here.
Who designed this?
An architect, just architected the daylights out of it. I don't really want to go there.
Right. Well,
I'm going to point that out though. That's a big deal.
yeah. So finally, under disadvantages, it can be difficult to build and maintain, and Will just gave us a great example of that too. So that pretty much wraps us up for talking about the 3-tier approach. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
In this episode, we talked about the 3-tier architecture, which evolved naturally as a result of, first the 1-tier architecture and then the economics that pushed that into a 2-tier architecture. The way that things are developed tends towards more and more tiers. And, and I briefly touched on this during the episode, but everything is evolving and getting more complex. And that's kind of where I wanted to go with this. We discussed Gall's law, and we have in the past, and that is the idea that complex systems evolve from simpler systems. And you're going to see this in your architecture of any app that you build. So, for instance, if I'm talking to a team lead, their definition of the front end is the web. Their definition of the business tier is the mid layer, and their definition of the back end is the database. If I'm talking to the guy that's writing the website code directly, the front end for him is the HTML and the bindings. The middle tier is all the controller logic and the business logic that's on the page itself to, make sure things stay correct. And the back end is the web server. You'll start to see this kind of start to evolve everywhere. Like it's a fractal differentiation of roles that happens all the way down. And so bear in mind that these sort of abstractions are there so that you can reason about things. They're not there because they are a thing. And that's all I got.
Stand by for Titanfall.
If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with the news about the show. Thanks for listening. See you next time.